Hello everybody, this is Mr. Bowman. Today we're going to be looking at the ALEKS topic outcomes and event probability with conditional probability. So 3 beans are selected from a large jar containing equal amounts of white and red beans. An outcome is represented by a string of these 3 letters here. So the first one was red, second's white, and third is white. So they go in order. The 8 outcomes are listed below. Assume that each outcome has the same probability. Complete the following, write your answers as fractions. So check the outcomes for each of the 3 events below, then enter the probability. So we're going to put every possible option and count them up to get our probability. So at least 1 red bean on the last 2 choices. So I'm ignoring the first one entirely and just looking at the last 2. If either one's an R, I'm going to check that one. So this one is all white, so that doesn't work. The last one's an R, so that's fine. Okay, and it says at least 1, so RR also works. WW is no good. WR, RW, RR. So that's 6 out of my 8, which I do want to reduce, so that's going to be 3 out of 4. Here, no red beans on the first 2, so I need a WW something. So WW, WW, WR, nope, 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 and nope. So 2 out of my 8, because I want no red, so I want white, white, but I can do white, 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 or white, white, red, because it didn't say anything about the third one. So that's 2 out of 8, or 1/4. Here, excuse me, here we want and, so at least 1 red bean on the last 2, and no red beans on the first 2. So it says and, right? So I'm looking for an overlap. So this doesn't overlap, it's only in the first. So the overlap one is right here, because it's checked in both rows. So that's 1 out of 8. Okay. Suppose there's at least 1 red bean on the last 2 choices. So we know it's an event A. This will limit the possible outcomes, right? Because since these aren't checked, they're now blank. So those don't count. For the remaining outcomes, check the outcomes for event B, then enter the probability that event B occurs given that event A occurs. So looking at this, I'm going to check all the ones that are here that are also down here, and that's only one option. Okay, because this one has been knocked out, that's the only one left. So the probability right now is 1 out of 6. Since those 2 are gone, there's only 6 possible options. So given the following probabilities, okay, so we're going to find these. So what's the probability of A and B is 1/8 divided by the probability of A. So 1/8 divided by 3/4. So we can jump and do that quickly. If I hit 1 divided by 8, that would help. 1/8 divided by all right, let's just work this out. 1/8 divided by 3/4 is going to be the same as times 4/3. So when I multiply these, I end up with, well, I can reduce these to 1 over 6. And the probability, because it's 1 times 1, so 2 times 3, should probably mention that. The probability of B given A, that's what that symbol means, is given. So the probability of B given A is this, so that's 1/6. So these must be equal.